this lesson, we're going to talk about linear functions with respect to slope. So what makes a function linear? A linear function is a function that has a constant rate of change. All functions have a rate of change, but a linear function is the only function where the rate of change is constant, meaning it's not changing at all. We know this constant rate of change as the slope of the line. The slope is the steepness and direction of the line. There are 4 different types of slope. There's positive or increasing slope, negative or decreasing slope, zero slope, and undefined slope. Okay, we're going to look at finding the slope graphically, numerically, and symbolically. So let's start off graphically. So our slope, remember, is the change in steepness and the change in direction. Slope is usually delineated with a letter M, and that's the change in my steepness over the change in the direction. So my steepness is represented by my y values, and the direction is represented with the x values. So what I can do graphically is just find 2 points that I could read very easily. First point I'm going to use is 0, -4. The second point I'm going to use is 2, 2. I'm just going to count how far did it take me to go from the first point to the second point, from left to right. So in order to go from -4 all the way to +2, I moved 1, 2, 3 blocks, or 6 places. Okay, be careful with the scale on your x and y axis. Okay, to go from 0 all the way to +2, we moved over 2 blocks. So my slope here, when I reduce this fraction, is 3. Let's try that again. I'm going to use this point here, 0, 5, and this point here, 3, 3. Okay, notice how we're going down to get to 3. I moved down 2 blocks, so that's a -2. To go from 0 to 3 on the x-axis, we moved over 3 blocks, so my slope is -2/3. Okay, finding slope numerically is the same sort of idea. We're looking at how the y values are changing and how the x values are changing. So when I look at my first table here and I look at my y values, I notice how my y values are going down by 1. My x values, I notice, are going up by 2. So my slope for the first table is -1/2. For the second table, I look at my y values and I notice I'm going up by 5 each time. When I look at my x values, I notice I'm going up by 2 each time. So for the second table, my slope is 5/2. Lastly is finding the slope symbolically. In order to do so, we're going to use a formula. If we have 2 points that are on the same line, x1, y1, and x2, y2, we can find the slope by using the formula y2 minus y1 divided by x2 minus x1. And this again is showing us the change in our y values and dividing it by the change in our x values. So we're going to use this formula to find the slope of the following sets of points. For example A, I have negative 8 minus a negative 2 divided by negative 5 minus a negative 3. Negative 8 minus 2 is negative 6 divided by negative 2. Our slope is a positive 3 when we reduce the fraction. Example B, we have negative 2 minus a negative 2 divided by negative 5 minus a negative 3. Negative 2 plus 2 is 0 divided by a negative 2. My slope is 0. Last example, example C. We have negative 8 minus a negative 2 divided by negative 3 minus a negative 3. So I have negative 6 divided by 0. We know we can't have a division by 0, so this value is undefined.